this lesson is on ellipse 9D, and the key thing I want to point out about how do we recognize this ellipse is the fact that we have both an x squared plus a y squared term. Now notice we have a and b, and those are the coefficients, and those have to be different, okay? So, and that's the key. If they were the same, then it would be a circle. But the fact they're different, now we have an elongated circle, and we see that stretching activity, okay? Now, we have two different orientations of the ellipse itself. We have a horizontal and a vertical. How do you determine which one it is? What we're looking for is this A and B value. A is always the bigger one, and B is always the small one, okay? So I'll put small over here. And being that the big one is under the X, then we know that it's a horizontal orientation. So let's go ahead and start plotting the points. H comma K is your center, and that's going to go here. And again, I want to draw everything out first. I'm not worried about filling these things in. In fact, in these examples, I'm not going to fill those in. I'll just talk about them. So let's go ahead and label the center HK. Now we have basically two axes. We have the major axis, which is the longer one, and that's going to be the major. And the distance from the center to the outside is A, right? And this point out here is called basically a vertex. Then the other diagonal is this thing called the minor axis. I'm sorry, not diagonal, minor axis. And this point up here is called a co-vertex. So what we have here is the distance from the center to the outside is basically B. Okay. Now we have this equation down here, c squared is equal to a squared minus b squared. I like to think of this as big minus small. And what this equation tells us, this distance of c is the distance from the center to a point out here called the foci, or the focus. Okay, we have one here, and we have one over here. And we use these to actually draw the curve. It's basically like, instead of having one center in a circle, you have two of these, and the ellipse goes around those. So the distance from here to the center is c. And again, we use the equations a squared minus b squared to get c squared. So that's the orientation we're talking about here. So we have distance of a along the major, distance of b along the minor, vertex, co-vertex, and also the vertices here and here, major and minor. And then, again, what's the major length? That's 2b, and the minor length is 2a. So let's see the same thing here in a vertical orientation. So here we have a center of h comma k, and then we have ourselves a major axis. And again, how do I know that? Because the a squared, the larger term, is under the y, and that tells me that. Okay, so again, there's my a value. If I'm looking at the minor axis, the distance from the center to the outside is b. Okay, so that's your minor. And then again, the c is always on the major. It's always on the bigger one. So I'm going to put my two foci in, and the distance again from here to here is c. Okay, and again, we use this right here. So again, the center is HK, and we can see everything here. I'm not going to go through and fill this all out again, but you can see it more graphically now, and that's what I want you to focus on. So let's go ahead and take a look at some examples. So this first example here, first thing I'm going to do is identify what's the center. And the center here is going to be 5, comma, -2. So again, I'm going to go over 5, 1, 2, 3, 4, 5, and then down 2. So there's the center. Now I'm going to identify my major axis. So this is the bigger number. So I'm along the y-axis. Now again, this is basically a squared. So to solve for a, you need to take the square root. So the square root of 9 is 3. So I'm going to go up 1, 2, 3, and then 1, 2, 3. Okay. And let's go ahead and put in the minor. I'll do it in a different color, in green. And again, this is b squared. Okay. So to take the square root of that, you're going to get 4. Square root of 4 is 2. Let's undo that right there. I'm trying to undo this. Give me a second. And let's get this mark out of the way. Give me 1 second here. There we go. Okay, so let's go ahead and draw this back in. Our major is up 3 and then down 3. Our minor is to the right 2, to the left 2. Now again, to get the c value, what I'm going to do is I'm going to write in big minus small, b squared minus, a squared minus b squared, And again, we're going to get here 5, which is equivalent to c squared. So again, to get c, you have to take the square root. So the square root of 5 is, a number between 2 and 3. So I'm going to go up a little more than 2, down a little more than 2, and get my points there. Now again, if I'm going to draw my actual curve in, those are just my guide points. I still have to draw the curve in, which is going to look like this. And there is my ellipse. So let's go ahead and draw in this information. I'm just going to move this information to the side here a little bit so we can see what's going on. Let's go ahead and draw in our points. So our major vertices are basically 5, -2, and then I went up at a total distance of 3. So I'm going to be at 5, 1. And then here, I'm going to be at 5, and notice I went down 3, so I'm going to be at -5. Okay, so for my major axis length, if I went up 3 and down 3, that's a total of 6, which is 2a. And our minor is a total of 4 across, which is simply 2 plus 2. Okay, now again, let's go ahead and put this on the same level. Put that in the wrong spot. Let me just rewrite this here. So we get in the same order. So we have again 5, 1, and then 5, -5. Now again, look at the minor. We're going to have the points basically doing a different color. So talking about, let's do them in green here. We have over 2 and back 2. So instead of being 5, we're going to be at 3, -2. And we're going to be at now 7, -2. Okay. Now for the foci, again, we're going to talk about points here. I'm going to do these in blue. We're going to be at 1 point and another point. Now again, I started at my vertex. So how do I show this? Is actually I'm going to give myself a little more room here because I want to show the proper way to show it. Let's just do 1 point for right now. And we're going to start at 5, -2. Now again, I went up. How much? I went up the square root of 5, and I went down the square root of 5. So if I showed another ordered pair, it would be 5, -2 minus the square root of 5. So that's what we're looking at there. And that's how you want to write that, because you don't want to put decimals here because it's, again, irrational numbers. You want to show us plus or minus the square root. Okay. So notice I was able to get the information after I made the drawing. So that's what I want to focus on. Let's go ahead and show one more example here. On this one here, what we want to do is put the center in at -3, 4. So back 3, up 4. Okay, and then we're going to go ahead and say, okay, the bigger number is under the x, so I'm going to take the square root of 16, which is 4, and I'm going to go to horizontally now and put my major points in. This is my minor axis because it's a smaller number, so I'm going to go square root of 4 up to square root of 4 down, which is 2 and 2. And again, I'm going to do big minus small. 16 minus 4 is equal to 12. And again, I'm going to take the square root of 12, which is the same thing as, 2 radical 3. And again, it's a sum number between 3 and 4. So I'm going to put a dot here for the focus just beyond 3 and right before 4. And in a different color, I'm going to sketch in my ellipse. So notice I was able to sketch everything in. Now I'm going to go back and I'm going to fill in the information. So again, my foci is going to be, let's just write this. This is really 2 points, but I'll write it. What do we have here? We have -3 plus or minus the square root of 12, which is 2 radical 3, comma 4. Okay. Then your majors are horizontally again. So again, I'm going to change the x value. So I started at -3 and I went to the left 4, so I'm going to be at -7, 4. And then I went to the right 4, so I'm going to be at 1, 4. For my minor vertices, the -3 doesn't change, but we do here. So we started at 4, we went up 2 to 6, and we have -3, and we went down 2 to 2. Okay, what's the major length? Well, we want a total 4 this way, 4 that way, for a total of 8, which is 2a. And the minor went up 2 and down 2 for a total of 4 this direction. Okay, so that shows a horizontal orientation of how to put these together. So again, you want to draw it first and then fill it all in. Next thing is, I want you to try this problem here. So notice the orientation based on your A and B. Draw it out first and then go ahead and fill in the information.